What we are going to be covering today is going to be limiting a reactant, and we're going to be doing a short experiment to be testing which reactant in our experiment is going to be the limiting reactant. So what limiting reactant means is it's whatever reactant that will limit the amount of product that can be made. We can also think about it as the reactant that we're going to run out of first. So if we were thinking about this as baking food, if we were trying to make cookies, and to make cookies we needed flour, sugar, and butter, and we had 50-pound bags of sugar and flour, but only a couple sticks of butter, we would run out of that butter first when we were making cookies. So that butter would be our limiting reactant. So it's whatever we run out of first and limits the amount of product that we can make. So we are going to be doing in this experiment just baking soda and vinegar. So we got baking soda and reacts with vinegar to produce carbon dioxide, water, and sodium acetate. So our two reactants are going to be baking soda and vinegar. So one of those will be the limiting reactant, and it's going to determine how much products we can make. So it's not as easy as just looking at it and seeing which one we got less of. When we're doing a reaction, we actually have to do some calculations to determine which one we're going to run out of first. So we're going to do the experiment, then we're going to go back, see what we got, and then do those calculations. So right now we got 4 different tests we're going to run. In our first trial A, we got 50 milliliters of vinegar and 3 grams of baking soda. In trial B, we got 100 milliliters of vinegar and 6 grams of baking soda. Trial C, we got 50 milliliters of vinegar and 1.5 grams of baking soda. And in trial D, 50 milliliters of vinegar and 6 grams of soda. So think to yourself and type in your hypothesis. Which one do you think will have the most carbon dioxide? And again, we're going to measure carbon dioxide just by size of balloon. So we're going to be capturing the carbon dioxide in balloons. So which one will have the most carbon dioxide? Which one do we think will have the least carbon dioxide? And maybe we could order the two in the middle as well. So type in your hypothesis now. So what I did from our last clip is I took all of our baking soda from our little cups. I've placed it into our balloons. So now when the reaction occurs, we can measure how much product we have by seeing how much carbon dioxide is produced in each balloon. We would expect the larger balloons means that we made more product, and the smaller balloons means we made less product. And we could use this with the amounts that were chosen here to determine which ones were baking soda or vinegar. That's what I'm talking about. Which one out of baking soda or vinegar would be our limiting reactant in each case. And then we can do our calculations after. So let's start our reactions, and you can see how much, oh man, we got a hole. We're gonna have to redo that one. All right, round 2. And we want our reactions to go all the way through. So we're going to give them a little bit of time to keep reacting. Give it the last one to go here. them all a little shake. Make sure they react all the way through. Like we're still getting some bubbles from that one. All right, so now we can see roughly the size of each of them. I would say B, the pink one, would be the largest. And C, the blue one, would be the smallest. Between A and D, let's take a closer look at A and D. Let's bring these up a little bit. They're pretty close, but I would probably say D might be a little bit bigger, but they're pretty close in size when we compare them to the other two. All right, so let's break down some questions, see what we're looking at here, and take a look at the actual chemistry behind this. Before we jump into the math, there's one more thing I want you guys to take a look at. The yellow balloon was trial A, the green balloon was trial B. It's always good to take observation of what you see in the flask still. So A looks pretty clear. If you take a look at flask B, you can see some white powder on the bottom, and that would be the baking soda still. So there's still some baking soda in flask D. So we can see that if there's baking soda left, our limiting reactant would have been vinegar in this one. So let's get to that math now. All right, so when we measured out our vinegar and baking soda, we did not measure it in moles. And our chemical equation here is measured in moles. So we need to do some conversions from whatever we measured it in to moles. So we're gonna have to find our molar mass here. So that's our first thing we gotta do. We should be experts in this by now. So calculate the molar mass of baking soda. All right, so what we gotta do, we need our periodic table. I'm going to assume you have your very own periodic table at home, or you could use this one online. And we should have been able to calculate that. Sodium was 23 grams per mole. Hydrogen is 1. Carbon is 12. And oxygen would be, we got 3 of them, times 16 each would be 48. So now we got to add 23 plus 1 plus 12 plus 48 all together, and we should have gotten about 84 grams per mole. All right, now calculate the molar mass of vinegar. So I know it's written kind of weird, but we got a COOH group right here. So we just have to count, we got 2 carbon, 4 hydrogen, and 2 oxygen, and you should be able to calculate that. All right, so let's do it now. We got carbon, remember we got 2 of them, and they weigh 12 each, that would be 24. For hydrogen, we have 1, 2, 3, 4, each weigh 1, so we got 4 there. And for oxygen, 1, 2, with a mass of 16 each. That would be 32. Add them all together. And our vinegar should have a molar mass of 60 grams per mole. All right, so our next step that we got to do is we have to look at how much baking soda, the mass of baking soda that we used in each of our trials. So we're just going to do 3 right now. So if we had 3 grams of baking soda, my question for you is, how many moles of baking soda did we use in trial 1? And the way we would figure this out, we have to use this molar mass here. And to go from grams to moles, we would divide by our molar mass. So for trial A, it would be 3 grams divided by 84 grams per mole. And we would get a very small number of moles. We could throw that in our calculator. 3 divided by 84 is equal to 0.0357 moles of baking soda. So that'll tell us how much is in A. And we could even write this right here. So 0.0375 or 357, excuse me, moles. Now let's take a look at trial B. Again, you just got twice as much baking soda, so we do the same thing here. 6 grams divided by 84. And that will equal, let's throw that in our calculator, 6 divided by 84 grams per mole equals 0.714, 0.0714 moles baking soda. And we can just throw that right in, 0.0714 moles. That would be the same for trial D too. So we could put D and B. .0714 moles. And then the last one we got to do is C. And in C we just have 1.5 grams. I want you to have some extra practice here, so figure this one out. All right, and then let's do it together. Just divide by the molar mass, 84 grams per mole. And throw it in your calculator. Divided by 84 grams per mole, and we got a really small number here. 0.01785, we're gonna round it up to 9 moles of baking soda. So let's put that in up here. So we got it, 0.0179 moles. All right, so with the vinegar, a little bit different. I don't expect you to know this, so I'm just going to explain it. Household vinegar is actually just 5% vinegar and 95% water. And we're going to use the water density to convert vinegar into mass. So real simply, what that means here is 50 milliliters of vinegar, and this is a very rough estimation, will be roughly 5 grams of pure vinegar, whereas 100 milliliters, 55% of that would be 2.5 grams. So 50 milliliters would be roughly 2.5 grams of vinegar, and 100 milliliters would be roughly 5 grams of vinegar. So we got 2.5, 5 grams, 50 milliliters would be 2.5 grams. And in D, we got 50 milliliters, so that would be roughly 2.5 grams. That is not something you got to worry about in any of the problems. You will never be asked to do that. We're just expected to be able to go from grams to moles. So now we know the grams. Let's figure out how to go from grams of vinegar into moles of vinegar, because that's what we want to do. So we know that vinegar, we figured out its molar mass is about 60 grams per mole. So let's do trial A first. So we got 2.5 grams there. Calculate the amount of moles of vinegar we used in trial A. This will be very similar to our baking soda problems. We start with 2.5 grams and we have to divide by our molar mass. So divided by 60 grams per mole. Need our calculator for this one. 2.5 divided by 60 and we get about 0.0417. We'll put that in here. 0.0417 moles. And you know what? We can use that same one for trial C and D. So we'll do C and D and A because those are all the same. So 0.0417, 0.0417, and those are moles. Now we can calculate our moles. I should probably put that here too. Our moles of vinegar in trial B. And again, I'll give you a shot to solve this one. It's good practice. We got 5 grams. Again, just divide by that molar mass. And let's put it in our calculator. 5 divided by 60, 0.0833 moles of vinegar. 0.0833 moles. All right. So from here, we can calculate our limiting reactants. So that's what we're going to be doing. All right, so as far as converting my moles in this chemical equation, it is as easy as we possibly can. So we have no coefficients here. So 1 mole of baking soda mixed with 1 mole of vinegar, will give us 1 mole of carbon dioxide, 1 mole of water, and 1 mole of sodium acetate. So everything here is 1. So all I have to do is figure out between baking soda and vinegar, which one's my limiting reactant, which one do I have less of, and whichever one it is, that is how many moles of each of my products I would be making. I want you to keep in mind, if my coefficients were different, I would have to do my mole conversions that we were practicing last week. But because all my moles are the same, you know, if I use 1 mole of vinegar, I'm going to be getting 1 mole of carbon dioxide. So it makes that part of the math really easy. So let's take a look at what our limiting reactant is in each case. So we'll do A and B together, and I'll ask you guys to complete C and D on your own. So all we got to do is we take a look at the amount of moles we had. So remember, I want 1 mole for every mole of baking soda. I'm going to be using 1 mole of vinegar. So I have to look at which one I have less of, and that will run out first in my reaction. So I have 0.0417 moles of vinegar, and I have 0.0357 moles of baking soda. So I have less baking soda. So in trial A, baking soda was my limiting reactant. Baking soda is limiting, which means that in my trial A, I used all of my baking soda. That's why you don't see any more baking soda there on the bottom. It all, I guess there's a little tiny bit left. Maybe the reaction's still going through. But it basically all got used up. And there still would be a little bit of vinegar in there if we were to taste it. So baking soda is limiting. Let's move to B. So B was with the pink one. And this was our biggest. And we can calculate, we got 0.0833 moles of vinegar, and we have 0.0714 moles of baking soda. So we had less moles of baking soda here. So baking soda is our limiting reactant because we had less of it here. Now, if we were to ask out of trial A and B, which one generated more carbon dioxide, we could even do that math right here. So we would be having, let's write all of A out right here. So we would have, and I'll move this down so we can see what's going on. 0.0357 moles of baking soda, and it would react with 0.0357 moles of vinegar. Not this amount. Remember, this is how much we had. This is how much we're using. So we still have some vinegar left over. And it would produce this exact same amount of each of these things. So I'm just going to write it one more time. It'll produce 0.0357 moles of carbon dioxide, 0.0357 moles of water, and 0.0357 moles of sodium acetate. If we're taking a look at B, and we could see B, we produce significantly more carbon dioxide. The reason is we had more of our limiting reactant. So instead of just having 0.057 moles of baking soda, this time I had 0.0714 moles. That means I also used up 0.0714 moles of vinegar. And if I wanted to talk about how much carbon dioxide I produced, because I used this much of each of these, I would be producing 0.0714 moles of carbon dioxide. All right, so now I'm going to ask you to find the limiting reactant in trial C. Would it be vinegar or would it be baking soda? All right, and our answer for trial C was baking soda, and it's because we got significantly less moles of baking soda. And we could think because baking sodas are limiting, that means that's how much of everything we use because we're using exactly the same amount of ingredients of everything here. So baking soda is limiting, so we would be using 0.0179 moles of this vinegar, and we would be getting 0.0179 moles of carbon dioxide. And you could see in trial C, it was by far the smallest. So that makes sense. All right, so next question for you guys. What's the limiting in trial D? And I know this is a little bit sloppy, so I'll say how many moles of vinegar and baking soda it was. We have 0.0417 moles of vinegar and 0.0714 moles of baking soda. All right, so in trial D, vinegar is our limiting reactant. That means we're going to have baking soda left over. And if you take a look here, you can see trial D is our only flask with a bunch of baking soda at the bottom, like a significant amount of baking soda at the bottom there. And all of the vinegar was reacted. So if I wanted to think of how much carbon dioxide was produced, or water or sodium acetate, I could take a look at any of them, it would be 0.0417 moles of carbon dioxide. And only 0.0417 moles of baking soda was used, so I would have some left over, so it does make sense. So we could take a look, if we remember our balloon sizes, let's take a look and see if that makes sense. I remember we said that B was by far the biggest, so, and C was the smallest, and A and D were kind of close, but I think we said A was third and D was second, but they were pretty close. So let's take a look at how much carbon dioxide was actually made in each one of them, and we would just be looking at our limiting reactant. So here we would have 0.0357 moles CO2. In B, it would be 0.0714 moles CO2. In trial C, it would be 0.0179 moles CO2. And in D, it would be limiting reactant was vinegar, so it would be 0.0417 moles CO2. So it makes perfect sense. We got the most in trial B, the next most in trial D, a little bit less in trial A, third most, and then by far the least in trial C. So that is how we can use the amount of ingredients to figure out the amount of product that I would expect to have. So it is a lot of math, but it's math that we've already practiced. We need to remember how to find molar mass, very important. We need to then remember how to convert into moles. And then we need to know how to see in our chemical equation how much we use in our reaction, or how much ingredients we need to make our product. You could think of it either way. So that's why those things are so important to figuring out our limiting reactant. We're going to be practicing this a lot this week. It will be on the test next week, but I want to reassure you this week's all about practicing this skill.